Alright, so we have a formula for the volume of a pyramid. And again, it's kind of a generic formula for the same reasons that it has been in the past. With pyramids, we have the formula volume equals 1/3 times capital B times H. Now, capital B is the area of the base. And the reason we can't put exact figures in there is because when it's a pyramid, the base could be any polygon. It could be a square, triangle, hexagon, octagon, and each of those have different formulas for the area of their base for their area. So we just put area of base here, and then depending on what shape you have on the bottom of your pyramid, you just adjust for that. So this is the formula I want to make sure you have in your notes for volume of a pyramid. Again, it's 1/3 area of the base times the height. And the height, one thing you want to know, the height is the distance from the bottom straight up to the top of the pyramid at its vertex. Okay, so here we have an example. So when you want to find the volume of a pyramid, you want to make sure you have the two parts that you need, the area of the base and the height. Okay, well, looking at the picture, I can see the height is labeled for me. The height is 6 inches for this pyramid. The area of the base, I want to go, okay, what shape is the base? And if I look at it, it's 4 by 4, it's a square. Okay, and then you have to go, okay, now how do I find the area of a square since that's the shape of my base? The area of a square is the side squared, or length times width. So I get 4 times 4, or 16 for the area of the base. Now realize the reason I use that formula for the area of the base is because it was a square shape. Had it been a triangle or a rectangle, I would have used a different formula. Okay. Now, once you have those two parts, the area of your base and your height, you go ahead and substitute those into the formula for the volume, and you finish. So we have 1/3 times 16 was the area of our base, times 6 was our height. Now, if you're not friendly with fractions, they scare you. What you can do here is do 16 times 6 and then divide by 3. Dividing by 3 is the same as multiplying by 1/3. But when you do, you should get 16 times 6 divided by 3. You should get 32, and this would be in cubic inches. Okay, so this was a pretty straightforward problem. We had a square on the bottom, which we're used to finding the area of a square. Pretty straightforward. Okay. This question that they say says determine the volume of a regular hexagonal pyramid. So pyramid, hexagon, remember, is a 6-sided figure with the base edge length of 2 centimeters and a height equal to the numerical value of the area of the base. Okay, and they do warn you this has a multi-step solution, and they give you hints as to what you need to do. Well, what would it look like? It's a hexagonal pyramid. Well, that means it has a hexagon on the bottom. Okay, and then comes to a point at the top. Okay, so it looks something like this, only prettier, I'm sure. It said the length of one edge is 2. So all around the base here, these are all length 2. And it said for the height of my pyramid, it says is equal to the numerical value of the area of the base. So not only do I need to find the area of the base so I know what the area of the base is, but the height, it says, is exactly the same. So this is kind of a different situation. So I need to decide what to do. So they give me a hint. They said to find the area of a hexagonal base, first cut it into 6 equilateral triangles, and then use what you know about 30, 60, 90 triangles to find the apothem. Now I have this on the next slide, kind of the steps broken down. Okay, so we have established we need to find B, the area of our base. Our base is a hexagon, okay? And for a hexagon, this is the formula for the area. It's 1/2 times the perimeter of the hexagon times the apothem. Now, what is the apothem? I will draw one for you. Okay, so here, down here, I have an example of a hexagon. The apothem is a line that goes from the center of a side, okay, to the center of the hexagon. This is my apothem right here. Right there. That would be the apothem. And we need to find the length of that so that we can calculate the area. Then once we have the area, then we can find the volume of our pyramid. So I have it broken down step by step. We're going to go one at a time. Using their hint, what we do is we cut the hexagon into 6 equilateral triangles. Okay, so I will do that. So we put lines through here. Okay, our hexagon is cut into 6 equilateral triangles. Well, the next thing that happens is if we look at these triangles, how many degrees would each of these angles be? Notice it's kind of a circle around the center, and the center of a circle has how many degrees? How many degrees are in a circle? 360. So we take that, sorry, I got my wrong tool here. Okay, we take those 360 degrees and divide them into 6 triangles, and we find that each of those angles is 60 degrees around the center of that hexagon. Okay, but what we're going to do next, okay, because now we have an equilateral triangle, the next thing we're going to do is this one at the bottom, so I can find my apothem. I'm going to use the apothem to split it in half. Okay, so now what measure is this angle? Well, it was 60 and I've cut it in half, so now it's 30 and a 60 here. So I have a 30, 60, 90 triangle. That's why they said in the hint, use what you know about 30, 60, 90 triangles to find the length of the apothem, because we cut it into 6 equilateral triangles, and then when we draw the apothem, it splits that triangle in half, giving us a length of 1 right here, because it's half of one of our sides. Okay, length of 1. The apothem is our long leg. This length 1 is our short leg, and then here we have our hypotenuse. So we need to find the apothem right here. It's the long leg of our 30, 60, 90 triangle. Hopefully you remember with 30, 60, 90 triangles how to find the long leg. Okay. If you look back at your notes, you should have that the long leg is equal to the short leg times the square root of 3. Our short leg is 1, so our long leg is going to be 1 times the square root of 3, or just square root 3. Okay, if you want to go ahead and round that, you can. Square root of 3 is 1.73. I'm going to cut it off there. Okay, so I found the length of my apothem. It's 1.73. Next, I'm going to find the perimeter of that hexagon. Why? Because I'm trying to find the area of the base. The two things you have to have for the area of the base are the apothem, which we just found out was 1.73, and the perimeter of that hexagon. Okay, so we need that. Well, it was a hexagon with all of the sides length 2. Okay, so what would the perimeter be? Well, for perimeter, you add all of the sides together. So our perimeter, we have 6 sides. They're all length 2. So you can either do 2 plus 2 plus 2 plus 2 6 times, or just do 6 times 2. Okay, so my perimeter is 12. All right, so now we have the area of our hexagon. Okay, okay, let's go back through our steps. The first thing we did was cut our hexagon into 6 equilateral triangles. And then when we drew the apothem, we split one of them in half, and then had a 30, 60, 90 triangle. Our apothem was the long leg from that triangle, so we took half of our base, one of our edges, for our short side, okay, and we took it times the square root of 3 to find that long leg, again, which was our apothem. We then found the perimeter of our hexagon. We went back to the fact that all of the edges are 2, There were 6 edges in a hexagon, so we had a perimeter of 12. We're now going to use that to find our area. Okay, again, area of a hexagon is 1/2 times the perimeter, which was 12, times the apothem, which we found was 1.73. Okay, with that I get 10.38 for the area of my hexagon base. So now let's regroup and say, well, what were we doing all of this for? We were doing all of this to find the volume of this pyramid that had a hexagon base with the edges length 2 and whose height was the same as the area of its base. So here is our formula for the volume of a pyramid. Let's fill in the information we have. We're going to do 1/3 times. The area of our base was 10.38. We just found that. And then times the height. And this doesn't happen all the time, but in the instructions for this problem, it said that the height was going to be the same as our area of our base. So 10.38 would also be our height because of what they told us. And now we just calculate that. So I'm going to take 10.38 times 10.38 and divide it by 3, or take it times 1/3. And I get 35.9 approximately. For the volume, and that would be in cubic centimeters, that's the volume of my hexagonal pyramid with a base edge length 2 and a height whose numerical value is the same as the area of the base. Tough problem.